Oh man, it's fried. This motor right here, completely gone. So these two motors drive those big paddle wheels directly, right? Which means it's super low, almost touching the water. Look, you can see the rust already. And now this one? Yep, finally gave up. So I've got to figure out how to redesign this thing. This time I'm building an actual boat, Crossriver. Here's the deal. The motors burned out because they were sitting too close to the water. So I've got to fix it from the ground up. And honestly, the solution's simple. Just raise the motors, get them higher, keep them dry. That way, the motor doesn't have to sit right on the wheel's axle anymore. But then the question is, how do I transfer the power down to the paddle wheel? The answer? A belt. Just wrap a rubber belt around the motor's output shaft and the wheel's axle. Boom! The wheel spins. Simple, right? Except when I actually started building it, I realized this wasn't just about waterproofing. It opened up a whole new avenue I didn't see coming. So here was the plan. One output shaft drives a belt. The belt drives one paddle wheel, and the middle shaft transfers power to the other wheel. Sounds straightforward, right? Not exactly. To lock that shaft tight inside the wheel, the whole size is gotta be dead on, even a tiny bit off. It just won't work. I ran into this before. Back when I built the N20 motor version, I learned that if you use PLA for the connector, after a few plugins, it loosens up. So I designed the shaft hole as a separate little piece you can swap fast. That way, no matter what shape the shaft is, I can 3D print a perfect matching connector. But back then the shaft was D-shaped easy, now it's round, so the fit has to be super tight. I redesigned the connector and printed in ABS. Tougher material should last longer, but I made the hole too small. The shaft wouldn't fit at all. So yeah, I grabbed a lighter and heated up the shaft. And when you hit ABS with hot metal, it warps, bends, totally loses shape. Now the wheel sits at a weird angle, and I'm worried the connector's gonna slip anyway. For now, I'll just make it work somehow. Then it hit me. I remembered this cheap TT motor I had laying around. A little gearbox motor with two output shafts. And here's the cool part. Both spin in the same speed, same direction. That's when it clicked. I don't even need that middle shaft anymore. Each output shaft can drive its own belt. Each belt drives its own wheel. The middle shaft, it just connects to two wheels now. No power transfer needed. And here's a bonus. With only one shaft and one belt, the belt pulls in one direction all the time. It wears the shaft down, bends it, destroys it. But with two shafts and two belts, the load spread evenly. Perfect balance. At that moment, everything just clicked. Every problem solved. Of course, new design means new problems. With two motors before, I could do differential steering. Left motor faster, right slower, both turns right. That's basically tank steering. It could turn on a dime. But now I've only got one motor. Both motors spin the same speed. So to steer, I need a rudder. I started researching. Most modern boats use propellers, so they only need one rudder. I thought, okay, one should be enough. Except not for paddle wheels. Turns out you need two rudders, one right behind each wheel to redirect the water properly. Otherwise, it barely turns at all. I checked how historic dual-wheel boats were built, and yep, that's exactly what they did. So I made a linkage system. A servo pulls a wire. The wire pulls a left arm, which turns the left rudder. Through a connecting link, the right rudder turns in sync. Right there, I finally had a complete boat. Engine, check. Steering, check. The first time, this felt like a real boat. Crossriver got a serious upgrade. Test it, and I admit it, I was nervous. New motor, new belt, new servo, new linkage, so many things that could go wrong. If anything failed, the boat would just become a sitting duck out in the lake. And I'm not swimming out there. Honestly, I should have tied a safety rope, but I felt confident. So I just launched it, no backup plan. Motor fired up. Belt spinning, rudder moving, everything working beautiful. Then I noticed something off. All the new linkage parts added extra weight in the back. And that's when I realized I forgot to balance weight. So the rear sinks deeper and the front lifts up. The whole thing nose up. It's supposed to float level, nice and balanced, but now half the components are underwater. That's a bummer, but not a deal breaker. Next time, I'm definitely bring those weights. But here's a bigger problem. The turning radius is huge, way bigger than I expected. I know rudders turn slower than differential drive, that's just physics, but watching how wide this thing swings still surprised me. Even with the rudders fully angled, it takes a massive arc to make a turn. In tight spaces, shallow water, weeds, that could be a real issue. I'd love to dig deeper into improving that, but realistically, if you want a tight turning radius, you need differential steering, 2 motors. And that brings us back to waterproofing headaches. It's always a trade-off, and I'm learning to live with it. Here's one cool thing that came out of all this. The control system feels so much better now. Before, with 2 motors, I had to use both sticks separately, like driving a tank. Want to turn left? You push one stick up and the other down. Total brain puzzle. Now, just one stick, 2 channels. Forward and back for speed, left and right for steering. Wanna go forward? Push forward. Turn left, push left. That's it. Pure instinct. No translation layer in my brain. For me as a pilot, that's a massive upgrade in control field. And that's pretty much it. The boat fully functions now. Waterproof, check. Motor, check. Steering, check. But here's what really matters. This isn't just an upgraded Crossriver. It's the first real boat I've ever built. Except for the motor and the O-ring, every mechanical part was designed and 3D printed by me. Building it from scratch taught me what a boat truly is. First, it's got a float. We solved that with milk bottles long ago. Simple but effective. Then add waterproof power, steering rudders, and linkage. All that complexity is just controlling how water moves. Here's something you might not know. The paddle wheel design I'm using has been around for over 1,000 years. It started in China, then spread worldwide. By the 1800s, American steamboats were using the same idea. The principle is identical to my Crossriver. So when I watch those paddles turning, I'm not just watching my own boat move, I'm watching history in motion. Experiencing how humans crack the code of shipbuilding, piece by piece, step by step. That's way more meaningful than just snapping a kit together. And I know one day I'll build another one, a propeller-driven boat, the modern way. But for now, I'm enjoying this one, the ancient way. That's what Crossriver means to me.